This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I want to talk about the decomposition of a function. So you might be given a problem that looks something like this. This says, express h of x equals x minus 7 squared as the composition of two functions, neither of which may equal x. So what they want you to do is, instead of having h of x, they want you to have a composition. So let's say we've got f compose g. In other words, our two functions are going to be f and g. And we want to say f compose g of x equals x minus 7 squared. So what we have to do is we have to find out what those two functions are. We have to find out what f of x equals. We have to find out what g of x equals. So for my first step, I'm going to rewrite this f compose g as f of g of x. And that equals x minus 7 squared. Now, let's think about this composition for a second. What this is saying is there was some function g, and that did something to an x. It changed it in some way. And whatever the result of that change was, we then performed function f on that change, and we ended up with x minus 7 squared. Okay, so if we look at that x minus 7 squared, it looks like the first thing that happened to the x was 7 was subtracted from it. So the inside function, this g function, would have been g of x equals, g of x equals x minus 7. What happened after we got to that x minus 7 was what the f function did. And the f function squared the x minus 7. So the f function must be a squaring function. In other words, f of x would equal x squared. Okay, so it looks like these should be the two functions that we're going to compose to get x minus 7 squared. Let's see if that works. So I'll take this f of g of x, and since I know that g of x equals x minus 7, I'll rewrite that as f of x minus 7. And what I want to find out is whether that equals x minus 7 squared. So I go to the f function. The f function says f of x equals x squared. So I've got to take x minus 7 and square that. I get x minus 7 squared does in fact equal x minus 7 squared. So now I know that the two functions I needed were f of x equals x squared and g of x equals x minus 7. Let me go over the steps one more time. I take the function and rewrite it as a composition, f compose g. Then I rewrite that f compose g in a more convenient form, f of g of x. And I write what that's supposed to equal. Then I look at that expression that I have, x minus 7 squared, and I ask myself, what happened to the x and what was the order it happened in? Well, the first thing that happened to the x was 7 was subtracted from it. So if the first thing that happens is 7 is subtracted from the x, that tells me what my inside function, in this case the g function, is. That was x minus 7. Then I ask myself, what happened next? Well, the thing that happened next was that x minus 7 got squared, so that must be the result of applying the outside function, the f function. So the f function must be the squaring function, f of x equals x squared. Those two functions together, when we compose them, are going to give me the result x minus 7 squared. Okay? Now, it's possible that you could have a function and you could decompose it in more than one way. Okay, so I just want to show you that that could happen. Let's take this function h of x equals x squared plus 5. So I'm going to rewrite that as f compose g of x equals x squared plus 5. And I want to find out what f and g would be, what those two functions would be. Okay, so I'll rewrite this f compose g as f of g of x equals x squared plus 5. And I want to ask myself, what happened to the x to turn it into x squared plus 5? And what was the order that those things happened in? Well, the first thing would have had to have been that the x got squared. So my g function, my inside function, is probably the squaring function. So g of x equals x squared. After the x was squared, 5 was added to it. So f of x would be equal to x plus 5. Okay, we can check that and see if that works. So f of g of x is going to turn into f of g of x squared. I'm sorry, f of x squared. And we want that to equal x squared plus 5. So let's see if we can make that happen. The f function says take the x, or whatever's in parentheses, and add 5 to it. So we're going to have x squared plus 5, and that of course equals x squared plus 5. Okay, so that would work. That's a possible answer. Now there's more than one way to do this. So let's say I get rid of that solution, and we'll see if there's another way that I can come up with. What if we said that the first thing that happened was that we took an x, squared it, and added 1. In other words, g of x is the same as x squared plus 1. And then in order to turn the result of that into x squared plus 5, f of x became x plus 4. Okay, so let's see if that would work. I've got f of g of x. I'm going to rewrite that as f of x squared plus 1. We want to see if I can get that to equal x squared plus 5. The f function, this time I'm saying that that equals x plus 4. So I'm going to have x squared plus 1 plus 4. We want to know if that equals x squared plus 5. We take the parentheses away and add everything together. We get x squared plus 5 equals x squared plus 5. Okay, so basically what I wanted you to see here is there's going to be, in some cases, more than one solution to this decomposition. So if you're comparing your notes with somebody else, you may find the other person has a different answer than you, but you're both right. Okay, so that's about it. Take care. I'll see you next time.